So, geological time. It's a long time. You have to think differently about geological time than what you would think about human time. So geologic time spans the last 4.54 billion years. So basically ever since the Earth got created in the solar nebula hypothesis. Having said that, it's only really the last 500 million years ago that we know a lot about, and that's because of fossils. And as we said, fossils are the remains or the traces of prehistoric life. They help us quite a bit when we try to divide geologic time up. And so we divide geological time up into eons, and then eons are broken down into eras. Eras are broken down into smaller periods, and periods are broken down into smaller epochs. So when we look at 4.54 billion years, all of the time before 500 million years ago, we call the Precambrian era. And that is about 87% of all geologic time. And so after that, in the last, say, 500 million years, or the last 545 million years, life really exploded. And so we call that the Phanerozoic eon. So it's the explosion of life. It stands for visible life. So quickly, if we were to look at this whole section right here is about 87% of geologic time. And this section here is about 13% of geologic time. So the Phanerozoic, which we just talked about, is when life exploded. So this right here is about 545 million. That's a really important number. And so you don't really need to know these little sections of the Precambrian. Just know the Precambrian is an era, just like the Paleozoic, just like the Mesozoic, and just like the Cenozoic. A lot of people don't actually call it the Precambrian era. They just call it the Precambrian. And just to point out, the first period in this era, the Paleozoic era, where I'm shading in here, is the Cambrian. And that's the reason why this is called Precambrian time. So this really is what we spend most of our time talking about because of the use of fossils, and we know a lot more about it. So fossils of life forms which existed during limited segments of geologic time can be used as guides to the age of the rocks in which they are preserved. So already in this course we talked about guide fossils and index fossils. William Strata Smith had a little bit of a conversation about that. And in order for something to be a really good guide fossil, you have to be found over a wide area of Earth's surface, and the species must have been short-lived, geologically speaking. That's why I sometimes say that humans are probably going to be a really good candidate to be a guide fossil in the geological rock record in the future, because we exist on all continents, and we're probably only going to be here for a very small amount of time. The example in this course that I always talk about as a really good guide fossil would be the Olenellus trilobites, which can be found in the black shales of Conception Bay South. They immediately guide us to about 545 million years ago. So as soon as you see an Olenellus trilobite in a rock layer, you already know the age because it guides. In the Precambrian, really it was not a really good Earth. The atmosphere in the hydrosphere really wasn't supportive of very much life. Typically all you had was some single-celled organisms, some algae, some bacteria, some traces of soft-bodied organisms, but pretty much that's it. There was a lack of species that had hard body parts, so you really can't find many fossils in the present time. When life exploded 545 million years ago, the Precambrian era ended and we went into the Phanerozoic eon, so explosion of life. And the first era that we met in that eon was the Paleozoic. And so the Paleozoic is not just one age, it's the age of invertebrates, it's the age of fish, and it's the age of amphibians in that order. So typically we had invertebrates evolved into vertebrates. We saw our first land plants. Then we got into abundances of fish. And then we saw our lungfish evolved into amphibians. Amphibians then started to evolve into reptiles just before the Paleozoic ended. So even though the age of reptiles is the Mesozoic era, we actually know that they did evolve in the Paleozoic, but they dominated in the Mesozoic. At the end of the Paleozoic, we had a mass extinction. And it was a mass extinction of invertebrates. And trilobites are just one example of invertebrates. But there were a lot of marine species that actually went into extinction. We think that was possibly due to the breakup of the supercontinent called Pangaea. The Mesozoic era, age of reptiles, it's when reptiles dominated. Everybody thinks about dinosaurs, and it's true, dinosaurs did, dominate there. But there's lots of other different species of reptiles. Birds are seen during this time. Then, at the end of the Mesozoic, which was approximately about 65, 66 million years ago, we think that a meteor came out of space, struck the Earth. There is some thought that the meteor struck on the Yucatan Peninsula, halfway between North America and South America. There's a big hole in the ground there, and we think that that is the site of the meteorite impact, and we think that was the cause of the mass extinctions of reptiles that occurred at the end of the Mesozoic era. Then we started the Cenozoic era, which is the age of mammals, and we're still in the Cenozoic era right now. So mammals evolved, mammals dominated, flowering plants started to dominate, and so, yeah, we've had some mammals that became extinct, like, for example, 11,000 years ago at the end of the last ice age, like the mastodon, the mammoth, the saber-toothed cat, the large ground sloth, and the giant bison. We did have some mammals go extinct, but mammals are still dominant, and the Cenozoic is still into continuing. So we're going to look at some different evolutionary sequences. The biggest thing that I want you to see is that, like, even though the Paleozoic, which is right here to right here, that's known as the age of invertebrates. Invertebrates are believed to actually evolve down here in the Precambrian, and naturally we still have invertebrates in the Mesozoic and the Cenozoic. So the biggest thing I want you to see from this particular diagram is when things first evolved. Another example, reptiles evolved in the Paleozoic, right at the end of the Paleozoic, yet we call the Mesozoic the age of reptiles, and we still have reptiles now, but we don't recall the Cenozoic the age of reptiles, we call it the age of mammals. So it's just a little graphic that you can actually look at. Remember, I always say I-FLARM, I-F-L-A-R-M-B-H. Sometimes I go back and put an S here for the single-celled organisms that dominated in the Precambrian way back. So here's a different one. Here's what another teacher at another school uses. Since I found flying angels riding brooms, forget medicine. And that's their way of using a mnemonic to memorize the evolutionary sequence. So single-celled organisms, invertebrates, fish, first land plants, amphibians, reptiles, mammals, flowering plants, and mammals. So yeah, and you can look at the time at which these different species first evolved in terms of the eras that we have. Here's another pretty cool geological timescale. One thing I will say is that you need to be very careful when you look at geological timescales. There's a lot of different versions out there, a lot, and so I'll circle that date. 4.6 billion years ago, approximately, when the Earth is believed to have first formed. And so that went on for a long time.